You would have seen from the Fortinet presentation that obviously PQC is a coming thing. So it's a risk that's emerging. It's been around for a little while, and probably in different regions it's been more mature than others. So some of the data I've got here is from the US. So in the US, it's around about 70% of organizations now are thinking about PQC and making purchasing decisions around the security based on PQC and understanding what post-quantum cryptography means and what quantum computing means to their organization. So it's something that's been, and mainly it's because their governments have been driving regulations to actually enforce that. There's some data I was looking at the other day for New Zealand, and at the moment your government's talking about what's the quantum regulations that they're going to come up with. Now, most likely what they'll come up with in the next few months will be something along the lines of you need to have a plan within the next year or two about post-quantum, and then by 2030 you need to have things implemented. Now, that's not a very long time, particularly when if you start understanding what that means for your network or your infrastructure or for your legacy applications or potentially for machinery that all may need to be protected at a post-quantum level. So it's a big thing coming up, so I highly recommend do some research, understand what's going on in this world, because I think in the next few months, in particular in New Zealand, it's going to make a lot of sense to you and really become one of those things similar to AI was about 6 to 12 months ago. Quantum will be the next thing that starts showing up in your day-to-day operations. But one of the key points there is, and one of the key points that Certes works towards, is that quantum readiness isn't about knowing there's a date. It's about understanding the challenges you've got today and how can you solve for those challenges today. So that's really what I want to talk about from Certes. I should introduce myself. My name's Bill Fraser. I'm the APAC Sales Director for Certes. I work with a bunch of government customers at the moment across Australia, New Zealand, and enterprise customers. So I'm here working with PB Tech to start talking about this in the environment of New Zealand. So you would have heard from the Fortinet presentation, harvest now, decrypt later. That's a big challenge. At the moment, you've got hackers potentially out there taking data that you've already got encrypted. It might be on your SD-WAN, it could be in your storage, it could be wherever. Basically, once they exfiltrate that data, they're putting it away. And they're putting it away for the next 3, 4, 5 years until they get access to a quantum computer. Once they get access to a quantum computer, they're going to be able to decrypt that data. So if you think about the data you're storing today and the information you have in transit today, if any of that will be a problem in 4 or 5 years' time, if someone can actually figure out what it is, then you need to start looking at a solution here. And that's where we're saying quantum, a lot of harvesting going on at the moment. I think there was, I can't remember the vendor in Australia, but they are saying about 60 to 70% of data that's being stolen from organizations actually isn't being used for ransomware. It's just literally being put away for another day and seeing what happens when quantum computing comes along. And one of the biggest challenges around that is that traditional security is looking at the perimeter. Now, the perimeter's security is great and it's been worked very well up to now. There's been encryption and everything that works around that to keep everything protected. But as we're seeing with more of these attacks around that harvest now, decrypt later, the security from a perimeter perspective is not enough. They're looking at data and data in transit and stealing that data and taking it elsewhere. So Certes, we specialise in data in motion and protecting data in motion. We've been around since 2006, so we've been around for about 20 years. We're not new to this business. And we've got about 1,000 customers globally. Now, you probably have never heard of us because none of our customers ever talk about us. But also within this region in APAC, we've only got about 20 customers. Predominantly, they've been government, so US government, UK government, multinationals, but more and more we're moving into finance, healthcare, and even more and more around the PQC side of things into everyday and regular environments because of the challenge that's coming with PQC. Our differentiator is very much around looking at data-centric protection. So we protect the payload only. We don't protect anything else. We don't protect infrastructure. We don't protect anything outside of that. We separate security from the infrastructure you have. Why we do that is to make sure that it's the security and the data protection itself is agnostic to what you have before. So you'll still need your Fortinets and you still need Trend Micros and Trend AI, and those other devices to monitor and look at where this data goes. But we're an overlay to uplift your security profile to make sure that you're ready for PQC. So in an ideal world, you're going to have lots of time, lots of budget, and be able to solve for this problem that's going to come at you in the next 6 months. You're probably not. So what you need to do is think about ways around that. And again, that's where Certes sits. We protect the packet only. We look at IP packets. We use it with quantum safe algorithms. So our algorithms align to NIST standards. Once you understand that read a bit more about PQC, you'll hear about NIST. You'll hear about FIP certified infrastructure. You'll hear about different algorithms, and we follow all the ones that are related to NIST in that area. And why we say any application, any infrastructure, anywhere, is because we are our solution itself is low touch. It's simply a piece of software. Now it can be applied to your network as a piece of hardware. It can be on a Nutanix device. It can be as an agent on a server or an agent on a laptop. So it's very low touch. It's effectively allowed to a bridge and almost invisible on your network. So it makes it really simple to implement and simple to upgrade your networks. There's no impact on your applications that you currently run, no impact on your network. So you don't have to change anything, which is really important, particularly when you're thinking about planning the long-term goal of solving for post-quantum. We talk about data protection and risk mitigation, a bit wordy, basically saying what I just said before. It's a software solution designed to protect data in motion. Again, I think we'll send these slides out to you after the event. Key components, there's 4 key components. First one being, sorry, there should be 5. First one being that it's a post-quantum solution. Second one being crypto segmentation. So we can actually logically separate data flows within a network. Now, it's not a tunneling device. We don't use IPsec. We don't use any of the VPN type solutions. It's a patent that we have, and we can separate those critical flows of information into crypto segmentation and make them separate from each other. The reason that's important is particularly when you might have an attack. Some of those flows, or a flow, may be impacted by that attack. The other flows will be completely independent and separate from the attack. When we start talking about the solution itself, we talk about keys and key rotations that are available on each of those flows. Each individual flow has its own separate rotation. So I don't want to get too much into product conversation here, but essentially you're extremely well looked after from a segmentation perspective. Like I said before, layer 4 data payload protection. So it's only protecting the payload. We don't impact IP, we don't impact the headers. So your routing platforms can still send the data where it wants to go. Your SOC can still see where it's going. Your SIEMs can still look at the information that's going through. But your payload itself is protected by a quantum safe wrapper. Customer controlled key management. So control of the data itself is completely sovereign to the customer. A conversation around sovereignty is pretty important because obviously it's normally linked to geographical locations, but we look at sovereignty as the customer themselves. So if the customer's got access to it, they're the only ones that has access to the information. So there's no vendor input into the key rotations or the key material that comes together. So you own the keys, you only have access to the keys, no one else does. And then finally, there is reporting that comes out and that can be fed into any infrastructure that you have currently. So just to give you an idea of a couple of customers, this one's a very large, actually the 2 large customers. This one's a global credit card company. They have around about, I think, 400 devices. 400 software instances across the network. We're now part of their operating platform. And what I mean by that is every time they go to a new data center or a new new region, they deploy a Certes enforcement point, and therefore their data is protected from that point back into their own network. So this is a very large organization. There's a significant amount of data that goes across. And since deployment, we're very proud there's not been one single breach, which obviously is a bit of a touch wood moment, but we're very confident in our security and the platform, again, because of the reasons said before. Also, the EU is a customer as well. So 27 member EU states, they all have enforcement points in their network. It's basically around bio data, passport control, things like that. So we're protecting extremely sensitive data. And this is kind of, I guess, the history of our company and where we've been. And now we're moving into more the PQC world, where it's a bit more generic and a bit more needed by, I guess, a broader set of customers. Just reinforcing what I said before about layer 4. Very different to what potentially a different vendors look at it from an IPsec perspective. We don't use IPsec. We very much focus on layer 4 encryption. And again, I said before that what that means, we focus on the data itself. We don't actually blind the data. So we don't blind, the IP headers or any of the addressing that's there. That's really important, I guess, from a monitoring perspective. So you can still see it where it goes in your network. And it's a patent we have. No one else does it like this. And it's been very successful for us over the last few years as well. So when you start talking about PQC, you need to start talking about keys. So you probably already talked about encryption and keys that are available. PQC is a little bit different. You need to add some different elements. So the elements that make up our key technology, one of them is a quantum random number generator. So this is actually a random number that gets generated, and traditionally that's what vendors will use to say that makes us PQC compliant. We take it a step further, and we add in 2 other elements. One of them is a policy that you define. So when you're building out this solution, you build policies, and those policies basically say any data that goes from application here to a depository here will be protected in a certain way. So that policy will build out certain information, and that information will be fed into the key. The other third part of it is actually customer information. There is information that you as a customer input, and that forms a third part of the key. Now, all 3 pieces have to come together to produce the key, and those keys get built within the enforcement points. Then the data can either be encrypted or decrypted as per your policy. So that's where it becomes very difficult for bad actors to intercept the traffic and actually decrypt this data. First of all, from a PQC perspective, we've got algorithms covering that, but also the key material. We don't send any key across the network in its entirety. We only send key material. So the enforcement points themselves build the key and then apply the policy, which is super important because, again, if a hacker tries to exfiltrate, somehow gets their hand on parts of the key, they still can't impact, they still can't break the PQC algorithms. So this could potentially be, I guess, a rollout of what it would look like working with Certes from a deployment perspective. So when we first started, we started in the hardware, so it was literally a piece of hardware with software on it. So that bottom right section where we would provide a customer with an appliance, and that appliance would protect like a branch or some sort of physical location. As you can see there, the CEP means Certes Enforcement Point, and any of those blue dots on the network effectively is where we would place an enforcement point. CPE would be your router, could be a Fortinet router, could be whatever you've got currently. But essentially you can see where we place those enforcement points in front of the data before it hits the network and before it sends it on its way. So originally we started with appliances, we then moved to cloud. So we built virtual cloud instances. We've got a cloud instance for AWS and Azure, but then we found that the difficulty with that is we couldn't move to infrastructure as a service or private clouds or other versions because they all have slightly different ways of handling security. So then we moved across to the left-hand side and we created a server agent. So now server agents, and this is a virtual server agent, can be applied to hardware. So you can have a physical hardware in your office, for example, or it can also be applied into the cloud. So if you've got multi-cloud, you can actually have virtual server agents sitting in the cloud as well to protect your data between locations. And finally, we've just released version 7 of our software, and that enabled the end user clients to be applied to laptops. So we've got devices, for example, sitting out, let's say mining area. They might have laptops and they want to protect the data from it going from that laptop across untrusted networks back into a server farm somewhere. So they use that to solve that problem. So you can actually extend out and completely cover your network from a post-quantum perspective. So going back to what I started out around understanding that PQC or post-quantum is coming, there's a challenge for you. That challenge will take you quite a long time to develop solutions for because you'll need to change a lot of stuff in your network. What we can do is solve for that today. So we can solve today, we can solve the data in motion solution for you today, so then you can go back and work on the infrastructure applications. Essentially, I just want to leave you with this, is that effectively we can help provide PQC for any app, any infrastructure, anywhere. And if you've got the time, go to our website. There's actually a quantum readiness checklist to get a bit of an understanding of where you think you might sit. And obviously there's opportunity to reach out myself and the team post the event and have a conversation. But I just want to say thank you very much. Next steps, if you want to have a demonstration, I can absolutely do a demonstration of the platform for you. We've also got free proof of concept as well. So there's lots of things we can do. Come have a chat to myself and we can sort something out after the event. Thanks very much.